Hello everyone and welcome back to Newton's past paper review for grade 12. Today we'll be covering the physics topic work, energy and power, and we'll be attempting this past paper question 5 that we see on the screen. So getting right into it, let us read the question. The question says a loaded truck with a total mass of 5,000 kgs travels up a straight incline at a constant velocity of 15 meters per second. Constant velocity, that already indicates to us that the acceleration of the truck is zero because the velocity is constant. At the top of the incline, the truck is at a height of 55 meters above its starting point. The work done by frictional forces is 8.5 times 10 to the power 4 joules. Ignore the rotational effects of the wheels of the trucks. And they have drawn for us a diagram indicating the truck starting at 0 meters above the ground and its endpoint, which is 55 meters above the ground. There's the mass of the truck and there is the constant velocity at which the truck is moving. So the first question asks us to define power in words, and the definition of power is the rate at which work is done on an object, or the rate of energy transfer per unit time. Okay, question 5.2 asks draw a labeled free body diagram showing all the forces acting on the truck as it moves up the incline. Now, when drawing a free body diagram, one way to identify how many forces that should be acting on the object is by looking at the mark allocation. So this question has a mark allocation of 4 marks, meaning there should be 4 overall forces, meaning that forces which are split into their components, those will still count as one force. So there should be 4 overall forces on this truck. So we know there is an applied force which is causing the truck to move up the incline at a constant velocity. So that's 1. We know there is a frictional force going down opposite the direction of motion down the slope. So that will be our second force. Our third force is obviously the weight, which can be split into its 2 components, parallel to the slope and perpendicular to the slope. And lastly, we have the normal force. So let us just go and draw that in a diagram. So that is question 5.2. We have our slope and we have our truck. So we have our parallel component of gravity, we have our perpendicular component of gravity. So we have F perpendicular, we have F parallel. Then we have our applied force, F applied. Then we have our normal force, and not to forget our frictional force. Okay, so that is our free body diagram. Moving on to question 5.3. 5.3 states use the work energy theorem to calculate the work done by the engine of the truck to get it to the top of the incline. So firstly, the work that is being done by the engine of the truck is the applied work, because the engine of the truck supplies the applied force, and they want us to use the work energy theorem. So we have to write down our work energy theorem and then make use of that to solve for the work being done by the engine of the truck. So the work energy theorem, we know, states that the net work is equal to the change of kinetic energy of an object. However, we know from reading the question, they told us that the velocity of this truck was constant. So that means the kinetic energy did not change, because kinetic energy is given as a half mv squared. So if the velocity didn't change and the mass is also constant, that means that our change in kinetic energy is 0. So that means we have to substitute something here by the net work. And we know the net work is basically the sum of each work which is done on the truck by the different forces, meaning it will be the sum of the work done by the applied force, the work done by the frictional force, and the work done by the gravitational force. So we can write that as an expression. And remember, we need to indicate whether energy, which is work is energy, whether it is being removed from the system or added to the system. So we know that the applied force is in the direction of motion, so it will be positive. Then we have the work being done due to the frictional force, which is negative. So we subtract the work due to friction, and again the work done by the gravitational force, which is also negative. So we know the sum of those three must be equal to 0. And now we can substitute. We want to solve for the applied work. Why? Because that is the work which is done by the engine of the truck, and we know that is equal to the work done due to friction plus the work done due to gravity, mgh, right? And the work due to friction, they gave it to us as a value. They said work done by frictional forces is 8.5 times 10 to the power 4 joules. So we can go and we can substitute that in. 8.5 times 10 to the power 4, and substitute our mass is 5,000 kilograms. The gravitational acceleration is 9.8, and the height was 55 meters. And if we add those two together, then we should get 2.78 times 10 to the power 6 joules. Always indicate your units. Okay, so that is the work done by the engine of the truck to get to the top of the incline. Look at question 5.4. It asks us, calculate the average power delivered by the engine of the truck if the truck takes 60 seconds to reach the top of the incline. So they gave us a time value, and we've just defined power earlier as the rate at which work is done. Meaning we can write our formula for power. So 5.4 said power is the rate at which work is done. So work per unit time. And we've already solved for the work done by the engine, which was 2.78 times 10 to the power 6, and they gave us a time value of 60 seconds. And when substituting that into our calculator, we get the final answer to be 4.63 times 10 to the power 4 watts. Watts are the unit of power. Okay. Alright, so overall not too bad. The truck now returns down the same incline with a constant velocity of 15 meters per second. So now we have the same forces acting on the truck. Instead, this time the truck is moving down the incline instead of up, which means the applied force now is acting down instead of up. The only force acting upwards will be the force of friction. So basically, in the second scenario, the applied force will be here acting downwards, whereas the frictional force will be here acting upward. Now they ask us, how will the work done by the engine of the truck on reaching the bottom of the incline compare to that calculated in question 5.3, which was here? Write down greater than, smaller than, or equal to, give a reason for your answer. So no calculation is required for this question, but if we quickly draw a free body diagram for the scenario where the truck is moving down, we have the applied force, we have the force, the parallel component of gravity, we have the applied force, and we have friction going up, right? And obviously we have our perpendicular force of gravity and our normal force, which we don't have to worry about because those are acting perpendicular to the direction of motion, meaning they do not do any work. So in the first scenario, the applied force had to overcome the frictional force as well as the gravitational force. However, in this scenario, the applied force coupled with the gravitational force, or the parallel component of the gravitational force, only has to overcome the frictional force. Can you see, notice in this scenario, the applied force has a force working together with it, whereas here the applied force is working alone. So obviously, given the fact that the velocity is the same, the applied force in the second scenario will have to be smaller than the applied force in the first scenario because it's working together with the gravitational force. And therefore, the work done by the engine, meaning the work done by the applied force on reaching the bottom of the incline, will be smaller than the work done in question 5.3 for the reasons we've just stated, because it's coupled with the parallel component of gravity. So the answer for 5.5.5, I can just write it here, 5.5 will be smaller than And they said give a reason. So the reason will be now that the weight, the gravitational force, does positive work on the truck. Because in the first scenario for question 5.3, we see that the weight did negative work, which means the applied force or the work done by the applied force had to be greater to overcome this. However, in this scenario, it does positive work because it's in the direction of motion, meaning the applied force has to be smaller because it's now coupled with the weight force and you're still maintaining that constant velocity. So the overall work done by the engine will therefore be smaller then. Okay, and that concludes question 5 on work, energy, and power. Thank you for watching.